afternoon to all. Am I audible? Am I audible? Can anyone message me? Please mention in the chat box. Okay then. Okay, I wanted to start the class at 2 p.m. but I was making some modifications in your presentation. In the presentation that I had to use to deliver the lecture. So that's why it took a very long time for me. Okay, almost 1 hour delayed. It's okay. So I wanted to make it more presentable. I made many modifications and changes in the PPT which I have prepared. So our topic is DC response and solution using Laplace transformation. So today I may discuss maybe RC response and RL response for DC supply, and using Laplace transform how to get the solution. So for that, first of all, we must have the basic knowledge of Laplace transformation. So we must have the basic knowledge of Laplace transformation. So for that, I thought first of all, let me just briefly discuss about Laplace transformation, and we will proceed. We will get into our topic later. So Laplace transformation. Laplace transform is what? It is a mathematical tool which can be used to convert differential equations in time domain into algebraic equations in frequency domain. Okay, so if we have mathematical equations which vary, which you write with respect to time. Okay, so if you are writing the mathematical equations with respect to time, you can convert them into the mathematical equations which vary with respect to frequency. Okay, so in general, what we do, we usually write the mathematical equations which are usually differential equations, and these are usually written in time domain. In general, whenever we write mathematical equations, we write the differential equations for the given circuit in time domain. So you can instead of writing the differential equations time domain, you can write the mathematical equation instead of differential equations. You can write algebraic equations instead of time domain. You can go for frequency domain. Frequency domain is also known as S domain. Frequency domain is also known as S domain. So usually we can simply mention current I in the given circuit, or we can say I of t. So what is meant by I of t? I is the function of time. I of t means, here I have written C, current. You can simply write I or I of t. I of t represents what? I is the function of time. Now if I want to, so here it is in time domain. So if I don't want the terms to be represented in time domain, if I want to represent them in frequency domain, or you can call it as S domain. Okay, so in S domain. So if you want to represent them in S domain, simply what you have to do is, instead of I of t, what you can write? I of S. You can write I of S. Okay, instead of I of t, you can write I of S. So I of S is nothing but Laplace form of the time domain term. Okay, so means that differential equations, all the terms vary with respect to time of the differential equations, whereas in the algebraic equations, all the terms will be function of frequency. Okay, in time domain, all the terms are functions of time. In algebraic equations, all the terms are functions of frequency. That's it. All the variables are functions of, not terms, variables are functions of frequency. Okay, so here I of t is the function of time, here I of s. So I is current is function of time here. If you are writing like I of s, then it means that current is function of frequency. That's it. Means as frequency varies, current will vary. Okay, this means that as frequency varies, current will vary. This means that as time varies, current will vary. That's it. So if you are representing the the different means the equations that you are writing, okay, for the given circuit in algebraic form, which are functions of frequency or which vary with respect to frequency, then such equations you can call them call as they are written in Laplace form. Okay, you can call those equations are written in Laplace form. Okay, so if you have in general all the terms, everything, every variable will be function of time only. Okay, for the given system, for the given electrical circuit, you can write the differential equations in time domain only. So if you want them to convert, into Laplace form, or if you want to convert the differential equations that you have written in algebraic form, okay, if you want to convert differential equations to algebraic equations, that means the equations which were varying with respect to time, if you want to convert them into the equations which vary with respect to frequency, then simply what you can do, instead of if you have a term I of t, instead of I of t you can write I of s. Symbol of Laplace is this. This is the symbol of Laplace. Okay, so Laplace of I of t is what? I of s. Okay, Laplace of I of t is I of s. So simply what you have done, current was varying with respect to time, you have converted into the current which varies with respect to frequency. The current which was varying with respect to time, it has been converted into the current which is about to vary with respect to frequency. So if you have time domain terms, you can convert them into Laplace form, means the terms which vary with respect to frequency, by simply using this symbol. This is the symbol of Laplace. So Laplace of I of t, you will get I of s. Okay, I hope you have understood. Okay, so if an electrical circuit is given to you, if you are writing the differential equation, usually you write d by dt of d square by dt square and so on. Okay, I of t, v of t, we will write like those. Okay, instead of that, we can go for algebraic equations. So these equations, algebraic equations, are the one which vary with respect to frequency. So directly there are some formulas which are to be used whenever you want to convert time domain terms into Laplace form. So these are some formulas I'm showing you here. So here you can see this is u of t. So u of t means unit step. U of t means unit step. Okay, step input. It is known as step input. This is a step. You know stairs, we climb these stairs, isn't it? We climb these stairs. If this is our first step, next what? Second step, third step, and so on. Okay, we climb these stairs. We call each stair as a step. Okay, each stair is called as a step. So u of t means step in. Okay, one step. One step is known as u of t, step input. We call it as step input. And if the step value, this length is 1, if step value is 1, it can have some magnitude also. Okay, so it is known as unit step input. Okay, it is known as unit step. You know sine wave, isn't it? You know sine wave. You people also know square wave. I'm unable to draw the square. You people also know the square wave, ramp wave. Okay, so this is our square wave. I'm trying to draw the square wave. Okay, so it's not exactly so, but it's looking like square wave and so on. Okay, so we can even give input as instead of sine wave or square wave, you can give a step input. So step length, step value, if it is 1, that is known as u of t, that is unit step. U of t means, u means unit. Unit step. Unit step means its value is equal to what? 1. Okay. So its value is equal to 1. So Laplace, this is Laplace symbol. Laplace of unit step is 1 by s. Okay, Laplace of unit step is 1 by s. So I have one more formula here. Here you can see Laplace of unit step. What did I say? Step value is 1. Laplace of 1 is what? 1 by s. Laplace of 1 is 1 by s. Okay, so if you want to convert this time domain, if you see, I have written here f of t. Okay, Laplace of f of t. Laplace of f of t is nothing but f of s. What is f of s value here? 1 by s. What is f of t value? 1. So if f of t value is 1, that is u of t. If f of t value is 1, in Laplace form, instead of 1, what you should write? You should write 1 by s. Similarly, Laplace of t, if your time domain function or value is t, Laplace of t is 1 by s square. These are all the formulas. Laplace of t square is 2 by s cube. Laplace of t cube is 6 by s to the power of 4. Laplace of t to the power n is factorial of n by s to the power of n plus 1. Laplace of e power minus alpha t. This is alpha. Laplace of minus alpha t is 1 by s plus alpha. Laplace of alpha t is 1 by s minus alpha. Laplace of t into e power minus alpha t is 1 by s plus alpha whole square. Laplace of t into e power alpha t is 1 by s minus alpha whole square. Sorry. Laplace of t to the power of n e power minus alpha t is factorial of n divided by s plus alpha whole to the power of n plus 1. Okay, these are all the formulas. So if you want, you can write down this statement. You can write down Laplace transform and you can write down these 4 lines. You just write down these 4 lines and later just write down those 4 lines and write down this expression Laplace of current I of t is Laplace of I of t is I of s. Just take a minute. As soon as you complete, you mention in the chat box so that I will proceed. What do you mean this is important? Are you asking me, is this important? So your question is this important? This is important is there is a grammatical mistake. Huh? Is this important? Yeah, this is important. Yeah. So this is important. Yeah, that's why I'm taking this class, isn't it? All the topics are important. Yeah, these formulas are very, very important. You must have the knowledge of these formulas. You must know these formulas, okay? These formulas are easily available. These formulas, I'm changing this slide. These formulas, they are available even in the Google. You just search in the Google Laplace transformation formula. You will get these formulas. They are available in the internet. You can get all these formulas. A few more formulas you can see here in this slide. So all these formulas, you can get them from the internet. Okay. So no need to worry. They are easily available in the internet. Simply in the Google, you just go and type Laplace transformation formulas. You will get it. Okay, and mostly for electrical circuit subject, even though there are many formulas, some formulas you need to use only few formulas now and then. this 1 e power at, t power nt will not be there, sin a of t, cos a of t. Mostly these sort of terms you will come across while solving the numerical problems. This which are I'm just highlighting. These formulas usually you will come across. Okay. So while solving the numerical problems, you will get the idea. Now you don't worry. Okay, don't worry. They look maybe these formulas may not be there much familiar to you people, but don't worry now. You can easily get these formulas. If you want, you can take the screenshot of these formulas in your mobile or laptop, whichever you are using. Just take the screenshot of these formulas and save them. Okay. And now one more thing I want to discuss, that I said that if you have time domain terms, you can convert them into Laplace forms. Okay, this is it. If I have I of t, I can convert that into what? I of s. Now, if suppose I have I of s, if I have frequency domain terms, means I have an algebraic equation, I want to convert that equation into differential equation. Okay, so if I have I of s, then what I have to do is, I have to take the inverse Laplace. Inverse Laplace to the power of minus 1 of I of s I of inverse Laplace of I of s. If you take the inverse Laplace of I of s, then you will get I of t. One more thing, I don't know whether you people have observed or not. Time domain terms must be written in small letters. Frequency domain terms must be written in capital letters. Means Laplace transformation terms must be written in capital letters. If you observe, here I of t I have written in small letters. Laplace transform term I of s I have written in capital letters. Okay. Okay, this yes you can write small letter or capital letter, doesn't matter. Huh? S is not important. This I becomes capital for Laplace. I is small for time domain. So this is it. This is inverse Laplace. Inverse Laplace of I of s, you will get I of t. So if you have frequency domain, you can convert them into differential equations. Means algebraic equations can be converted into differential. Differential equations can be converted into algebraic. That's it. Okay. So if you want to convert differential equations into algebraic equations, then you have to take the Laplace transformation. If you want to convert algebraic equations into differential, then you have to go for inverse Laplace. Okay, you have to go for inverse Laplace. So I have some formula for inverse Laplace. Here you can see inverse Laplace of 1 by s is what? 1. Laplace of 1 is what? Laplace of 1 is 1 by s. If Laplace of 1 is 1 by s, this is Laplace. I will write this symbol. This is Laplace. Laplace of 1 is 1 by s. That means inverse Laplace of 1 by s should be 1. That's it. Inverse of the Laplace is nothing but inverse Laplace. Inverse Laplace of 1 by s to the power of n is t to the power of n minus 1 divided by factorial of n minus 1. Similarly, inverse Laplace of 1 by s minus 1 is 1 by s minus a is e power at. You just see here e power at. This is e power at. What is it? Laplace of e power at. What do you get? 1 by s minus a. Laplace of e power at is 1 by s minus a. Therefore, inverse Laplace of s minus a will be e power at. That's it. Inverse Laplace are the just opposite. Okay, just the same thing you will get when you go do the inverse. Time domain term, whatever it was there earlier, same thing we will get. Okay, so these formulas you can directly get from the internet. You just search inverse Laplace transformation formula. Just type in the Google inverse Laplace transformation formula. You will get this. I have mentioned only few formulas here. Okay. Okay, confused? Nothing to confuse here. Simply, if you have an electrical, you will get the clarity, Ashish, when we go to the theory. Okay, so this is just the beginning. No need to worry. It's just the beginning. You must have some knowledge. That's why I have been explaining. So I want to feed in your brain that there is something known as Laplace transform. So Laplace transform terms are written in terms of S. Time domain terms are written. Laplace transform terms are functions of S. Time domain terms are functions of T. That's what I wanted to feed in your brains. Okay, that's it. If you remember that, that is more than sufficient. Formulas, when you start solving the numerical problems, automatically you will get the idea. Don't worry. Okay, let us get into the actual subject, the concept for which I started this class. I wanted to take this class. So DC response and solution using Laplace transformation. So for that, first of all, I will start with RL circuit. RL circuit, DC response and solution using Laplace transform. RL circuit, DC response, and for this concept, you must have the basic knowledge of transients, initial condition and final condition. Okay, so basic knowledge of transients. So let us see the DC response of RL circuit and solution using Laplace transform method. So let us see, you can see here there is an R and L which are connected in series, and there is a switch here, and this is our DC source V of T. Okay, and current when supply is given, when switch is closed, current I of T will flow. Of course, we know that immediately as soon as switch is closed, inductor acts as short circuit, isn't it? So you must have the basic knowledge of transients, then only you will be able to understand. Inductor acts as short circuit as soon as switch is closed, immediately after switch closes. So what you people do is, you just write the title and draw the circuit. Write the title and draw the circuit, that's it. So if you have completed, you can read what I have written here. Inductor in the circuit is initially uncharged. Okay, it is initially uncharged. It acts as short circuit. Don't worry, I have been working on it, how to present this class in the simplest possible way. Okay, I wanted to start at 2 p.m. but I couldn't start because I was modifying the PPT. I made many modifications. I wanted to I want to make the PPT as simple as possible. Each and every step should be, you people should be able to understand each and every step. For that reason, have been doing modifications. Still I couldn't complete it, but I thought whatever modification that I have done till now, that is more than sufficient for to deliver the lecture now. That's why I just stopped and I started taking the class. Otherwise I wanted to postpone this class even for half an hour more, but I didn't do that because already 1 hour, with 1 hour delay I have started this class. So I hope you have written the title and you have drawn the circuit. Now what is there? In the circuit, what are all the passive elements? R and L are there, and source V of T is there. So we can apply KVL, isn't it? So as soon as switch closes, what will happen? Okay, we can determine the complete solution for current. Okay, as soon as switch closes, you can determine the complete solution of current. So apply KVL, write down applying KVL. What is it? V of T is equal to what? R into I of T plus L into di by dt. Okay, here I of T is there. Our current, we have as mentioned it as I of T. So we have to write, instead of I, you must write I of T. So V of T is equal to R into I of T plus L into d by dt of I of T. Consider it as equation number 1. So up to here, I think there is no confusion, isn't it? Up to here, there is no confusion. So here, what is V of T? V of T is the source. Okay, V of T is the source. I of T is the, I can say it is the it is one of the variable which varies with respect to time, and this variable is due to the source. Okay, when supply is given, current flows, isn't it? So source voltage. So source, whenever source is there, source voltage or current is there. So if you take the Laplace of source voltage, you will get V by S. You just remember that Laplace of source voltage V of t is V by S. Of course, I have already told you that if your input is 1 and unit u of t, for u of t, suppose unit step, if your input is u of t, okay, or if step input is given, its Laplace of u of t is 1 by s. Okay, source magnitude will be constant, isn't it? Magnitude will be constant. Okay, so and Laplace of 1 is what? 1 is 1 by s. So v into 1 by s. Okay, so v into 1 by s. V into 1 by s nothing but v by s. So for source Laplace, if you take the Laplace of source, okay, I have written here Laplace. So v by s. Next I of t. I of t is just a variable, so Laplace of I of t is nothing but I of s. Okay, Laplace of I of t is nothing but I of s. One more term is there here which varies with respect to time. Here three terms are there which are varying with respect to time. Okay, in this differential, this is a differential equation, isn't it? I have written here, see, I have written here differential equation. In this differential equation, what are all the variables? V of t, I of t, d by dt of I of t. V of t, someone has mentioned it might have been okay if you have I have taken the class at 8 p.m. But today is holiday, that's why I thought it's better to take the class at as early as possible. That's the reason I'm taking now. It's okay. I have anyhow I have started the class. I'll continue. That's it. So here how many variables are there? V of t is there, which are functions of time. I of t is there, and d by dt of I of t. Three terms are there which are functions of time. So v of t is nothing but source. So Laplace of v of t is v by s. Next Laplace of I of t is I of s, and Laplace of d by dt of I of t. D by dt. If you have d by dt, Laplace of d by dt you will get s into that term. So what is, okay, if you convert the differential term, okay, Laplace of d by dt term is s into that term. What is that term? Term is what is our variable? I of t. So s into I of s. Laplace of d by dt. But here we are writing this equation immediately after closing the switch. Immediately after closing the switch, you must, when you take the Laplace, you must also consider the initial condition. What is the initial condition? Current in the circuit as soon as switch is closed. Okay, initial condition means current in the circuit as soon as switch is closed. So whenever you are converting time domain into S domain, that is frequency domain. Okay, so when you are converting this time domain terms into frequency domain, that is S domain, at that time you must, if you are taking the differentiation, you must also consider the integration or differentiation. Whenever you are converting differentiation term into Laplace form or integral term into Laplace form, you must also consider the initial condition. What is the initial condition? Current as soon as switch is closed. Current in the circuit as soon as switch is closed. So what is the current in the circuit as soon as switch is closed? Current is I of 0 plus. Okay, current in the circuit as soon as 0 plus. What is meant by 0 here? At t equal to 0 plus, isn't it? Here 0 means at t equal to 0 plus. That's it. As soon as you close the switch, immediately after closing the switch, the time is what? Immediately after closing the switch, time is t is equal to 0 plus. Immediately after closing the switch, time is in time domain, it is 0 plus. Therefore, you must write the current in at initial condition for whenever you are writing the Laplace of differential term. Okay, so if you are writing the Laplace of differential term, that variable in Laplace, that is I of t in should be written as I of s multiplied with s domain term. That's into I of s. Differentiation of I of t is equal to what? Laplace of differentiated term. Okay, Laplace of d by dt. Laplace of d by dt of I of t is s into I of s plus initial condition term, that is I current at t equal to 0 plus time. Okay, so just note it down. This is the beginning. Even if you are unable to follow, it doesn't matter. While solving few more numerical problems and while discussing few more topics, you'll be able to, okay, as soon as I complete few more topics, you will be able to follow the lecture. It's the beginning, so you may have some confusion. It's okay. Okay, so Laplace of v of t is v by s. Laplace of I of t is I of s. Laplace of d by dt of I of t is s into I of s plus I of 0 plus s into I of s plus I of 0 plus. Okay, consider this as equation 1 and the other one as equation 2. I hope you might have written meanwhile I was discussing equation 1 and equation 2. Now what we have to do, you have to substitute equation 2 in equation 1. Okay, to substitute equation 2 in equation. What is equation 2? All these terms are equation 2. Okay, all these terms are equation, yeah, all these terms are equation 2 actually. Or what is the need to write equation 2? No need to write equation 2. Why? Because these are different terms. I will just remove this equation 2 from here and I will write it somewhere else so that it may be of some use. The dot is there. Okay, so I am considering. So now substitute this all these Laplace transformation formulas in equation 1. What do you get? So as soon as switch is closed, where is it? Yeah. Now this is what you will get. I have substituted all those terms in the above equation. Instead of Laplace of v of t is v by s, r into, r is constant, L is constant. Okay. Instead of I of t, I of s, and instead of d by dt of I of t, L into s into I of s plus I at current at 0 plus. Okay, so I have written small I. Why? Because it's the initial condition. Okay, so for initial condition, no need to write capital I and all. So when you are transforming the time domain term into Laplace, you have already transformed it. Okay, you have transformed it. D by dt of I of t is only s into I of s plus the initial condition you are writing. So for initial condition, you can write small I. Okay. Now, as soon as switch is closed at t equal to 0, what will happen? Current has to flow in the circuit. Okay, current has to flow in the circuit. So, inductor acts as what? Inductor acts as short circuit. Okay, the current flowing through inductor at t equal to 0 immediately. Okay, no current will flow. Of course, it is acting as a short circuit. Okay, it acts as short circuit or open circuit. What did I say? Am I telling in the reverse way? Inductor acts as short circuit or open circuit? Okay, if no current is flowing, that means that it is acting as open circuit, isn't it? I think instead of using the term open circuit, I am using the term short circuit. Yeah, I'm telling in the reverse way. Okay, yeah. So as soon as switch closes, inductor won't act as short circuit, acts as open circuit. Then only current cannot flow. If it is acting as short circuit, okay, so instead of telling open circuit, I have been using the term short circuit. Okay, current cannot flow through the inductor. When current cannot flow through the inductor, what does it mean? Inductor acts as open circuit. As soon as switch closes, inductor acts as open circuit. So no current can flow. So what is this current? As soon as switch closes, initial current is 0. Okay, initial current is 0 because inductor is acting as open circuit. Okay, it's not acting as short circuit. It acts as short circuit. So sorry. So I might have told open circuit. Okay, but I have been using the term short circuit, short circuit. Okay, so if it is short circuit, current cannot be 0. If current is 0, that means that it is open circuit. So as soon as switch closes, if you have the, that's what I was telling you. If you have the basic knowledge of transients, you will be able to understand this. Otherwise, you won't be able to understand. So immediately as soon as switch closes, so what will happen? Inductor acts as open circuit, not short circuit. So when it acting as open circuit, that means that the current is initially the current in the inductor is 0. So initial current is 0. So this above equation you can modify, and what you can write, V by S plus I of S into R plus L into S I of S plus 0. Okay, I can write one more equation here. I didn't write that. I can write it. So this equation just gets modified. So when inductor acts as open circuit, what will happen? The initial current becomes 0. So here instead of this, what I can write is this is 0. So if this is 0, what is left over? R into I of S plus L into S I of S plus 0. What will happen? L into I of S plus 0 means it is L into I of S. So here you can take I of S common, you will get I of, if you take I of S common, you will get, what will happen? I of S into R plus L of S you will get. So I of S is equal to what? I of S is equal to V by S divided by R plus SL or LS. Both are same. Okay. So it's my mistake. So actually inductor acts as open circuit as soon as switch closes. But I was keeping on telling you that it acts as short circuit. It was my mistake. So I hope you have written this. So I hope you have written. What you have to write here is simply taking Laplace transform, you will get this equation. This equation you have to write. After that you must mention that at t equal to 0, initial current is 0. As soon as switch closes at t equal to 0 plus, initial current is 0. Therefore, V by S is equal to R into I of S plus L into S I of S plus 0. Okay. And if you further take I of S common, you will get this, and from that you will get an expression for current. Expression for current is this. Till now, is there any confusion? Is there any confusion? Anyone? You can raise your hand or you can just mention in the chat box if you have any confusion till now. Am I confusing you or am I able to reach you people? I don't know. Okay. Only thing that you have to remember is you must know the formula of Laplace transformation, and you must know that as soon as switch closes, if there is an inductor, what will happen is inductor will act as open circuit. So current in the inductor is 0. So initial current will be 0. Okay. So I of S is equal to what? V by S by R plus LS. I hope you have written. Let us proceed further. So after that, so just I'm going to rearrange the terms. What is my aim is, I don't want any coefficient of s. Here s is there, coefficient of s is L. So I don't want this L value besides to L, besides to s. Okay, I don't want this L besides to s. So what I have done here, see in the next slide, I have taken L common. If you take L common, you will get R by L plus S. Okay, so R by L plus S you will get. So here I have interchanged the positions of S and L, because this equation, how you can write this equation here, V by S is there. Okay, so you can rewrite it actually. You can write the above equation, this first equation, you can write it as, actually this S and L both are coefficient to each other. I hope you are mathematics students, you need to modify. I am not going to modify. Okay, so here V by S, S is in the denominator, L is also in the denominator. So I am sending L is constant, of course V is also constant. So I am sending L to the numerator. I'm not sending it to the numerator. I'm writing in. It seems as if it is in the numerator, but S and L are both are coefficients, are what to say, coefficient to each other. So you can rewrite this as, so see here, in this both the equations are same. S, you know, S is in the denominator, L is also in the denominator. Okay, so instead of writing like this, okay, instead of writing like this, you can write like this: V by L whole divided by S into S plus R by L. Okay, so I wanted terms in the form of S plus something. Okay, S plus something. I don't want any coefficient of S. So that's why I have taken L common and I have just rearranged the terms. That is nothing else. I didn't do any modifications, just I have rearranged the terms. Okay, so this is it. I hope you have written. So I hope you have written. Now let us proceed further. Now what is my I of S? What is I of S? I of S is equal to V by L whole divided by S into S plus R by L. Now I want to determine the value of I of S. Okay. Why? Because already I have, I can't, actually I can't determine any numerical value of I of S. Okay. So I want to further simplify I of S. Why? Because I want to determine current in time domain, I of t. Okay. So I want to determine current in time domain, I of t. So I want to convert I of S into I of t. Okay, so if I want to convert I of S into I of t, what I should do? I must take the inverse Laplace of I of S. So now to take the inverse Laplace of I of S, whenever I of S term is there, what we have to do is, we have to go for partial fractions. Do you have the knowledge of partial fractions? Can anyone mention in the chat box? Do you have the knowledge of partial fractions? See, I am using partial fractions. So in the denominator, two terms are there. One is S, one is S plus R by L. Two terms. Okay. One is S and another term is S plus R by L. Two terms are there. So since two terms are there, you just write A by S plus B by S plus R by L. Okay. Of course, there is a numerator, but just leave it. So you have the knowledge of partial fractions. It's good. And then it will be easy for you to solve the numerical problem. So I of S is equal to what now? A by S plus B by S plus R by L. So I didn't know that you people already have the knowledge of Laplace transformation. That's why, okay, that's why I have wasted much time to make it more, means I wanted to make look the PPT as simple as possible so that even if you are not listening to me and if you are going through these slides, you should be able to follow that. So I have spent much time to make the modifications. So this is it. We have I of s, that is equal to V by L by S into S plus R by L. In denominator there are two terms, S and S plus R by L. So write down A by S plus B by S plus R by L and give some notation to it. Okay, some numbering. Notation means give some numbering to it. Some equation 4. Okay, I hope you have written. Now let us determine A. What is A? A is equal to, where is my pencil pen? I will take laser. Okay, A is equal to what? I of S into S at S is equal to 0. Okay, I of S into S at S is equal to 0. Okay, so what is I of S? I of S is, what is I of S? I will take pen. What is I of S? I of S equation is this. This is my I of S equation. What is it? V by L by S into S plus R by L. So V by L by S into S plus R by L is, this is my I of S. What is denominator of A? A is, denominator of A is S. So equate it to 0. So S, if you equate S to 0, this is it. Denominator, equating denominator to the 0. Denominator of A is what? S. Equate S to 0. So at S is equal to 0. So I of S into S at, so this S is what? This is the denominator of A, and at, if you equate that denominator to 0 at S equal to 0, that's what you will write. You should write. So A is equal to V by L by S into S plus R by L into S. So now if you have see here, this S and this S, they will cancel. What is left over? They both left over is V by L by S plus R by L at S equal to 0. Now substitute S equal to 0. So this will become 0. I have written here. This will, S will become 0. What is left over now? V by L by R by L. So V by L by R by L means L cancel. What is A? A is equal to V by R. A is equal to V by R. That's what you will get. Just write it down quickly. Write down A quickly. I hope you have understood how to determine A. Similarly, let us determine B. So what is the denominator of B? B denominator is S plus R by L. If you see in your notes, if you have written, it might be there. Denominator B is R by S. So what is, so I of S is equal to A by S plus B by S plus R by L. So B is equal to what? I of S into denominator at S is equal to, equate this denominator to 0. S plus R by L. Equate it to 0. If you equate it to 0, what is S? Equate R by L to 0. Okay, I am unable to write 0 here. My mouse is not listening to me. Equate R plus denominator to 0 of B. Denominator B is what? Denominator of B is S plus R by L. Equate it to 0. So what is S equal to? Minus R by L. Minus R by L. S is equal to minus R by L. So at S is equal to minus R by L, you have to write. So what is I of S? V by L by S plus R by L into S plus R by L at S is equal to minus R by L. So S plus R by L, S plus R by L cancel. What is left over? V by L by S. So now substitute S value here, minus R by L. So V by L by minus R by L, L cancel, minus V by R you will get. I hope you have understood. I hope you have understood how to determine A value and B value. Now substitute this 5 and 6, equation 5 and equation 6 in equation 4. Substitute 5 and 6 in equation 4. Substitute equation 5 and 6 in equation 4. So if you substitute 5 and 6 in equation 4, so what do you get? I hope you have completed. So if you substitute this in equation 4, you will get I of S is equal, this was our equation, I of S is equal to V by L by S plus S into S plus R by L, A by, that you have written in A by S plus B by S plus R by L. What is A? B by R. What is B? Minus V by R. V by R. Okay, now just to rearrange the terms, what do you get? I of S is equal to, you can take V by R common. If you take V by R common, what do you get? V by R into 1 by S minus this minus, you can write it here, minus 1 by S plus R by L. So this is our I of S equation after partial fractions. So after going for partial fractions, this is your I of S. Okay, so this is your I of S after partial fractions. Now you can go for V. V is constant, R is constant here. You can go for inverse Laplace transformation. So what is 1 by S? What is the inverse Laplace of 1 by S? I want to determine I of t here. Okay, so I want to determine I of t. So what is the inverse Laplace of 1 by S? Can anyone mention in the chat box? Inverse Laplace of 1 by S value. Inverse Laplace of 1 by S. And inverse Laplace of 1 by S plus R by L. 1 by S, R by L you consider it as A. 1 by S plus A. A is equal to what? R by L. Inverse Laplace of 1 by S and inverse Laplace of 1 by S plus R by L. So I will show you the formula. It will be better if I show you the formula. I will show you the formula so that you can recall. So I will just go back to the formula. Inverse Laplace. We want inverse Laplace. So what is the inverse Laplace of 1 by S? It is 1. And inverse Laplace of 1 by S minus A is e power at. So S plus A will be what? E power minus at. That's it. Okay. Inverse Laplace of 1 by S plus A. A is R by L. For our equation, A is R by L. So inverse Laplace of 1 by S plus A is e power minus at. Okay. So minus into minus you will get plus, isn't it? So take the inverse Laplace, applying inverse Laplace. I of t is what? V by R is constant. Keep it as it is. Inverse Laplace of 1 by S is 1. Inverse Laplace of 1 by S plus, what is it? 1 by S plus R by L. Inverse Laplace of 1 by S plus R by L. You can write it as what? You can write it as S minus of minus R by L. You can write it as what? S minus of minus R by L, isn't it? S minus of minus R by L. So S minus A. Minus R by L is what? Is A. So S minus A. S minus A. 1 divided by s minus a. What is a? A is equal to minus r by l. A is equal to minus r by l. So 1 by s minus a. What is the inverse Laplace of 1 by s minus a? Inverse Laplace. Inverse Laplace means like this. This is inverse Laplace. Inverse Laplace of, what is it? Inverse Laplace. What do you get? E power a t. E power a t. E power a t. What is a? A value is how much? Minus r by l. So you will get e power minus r by l. E power minus r by l. Okay. Of t. You are converting inverse. Whenever you are converting it into inverse form, whenever you are taking inverse Laplace, always remember in there I wanted to write L, isn't it? I am unable to write S. Minus R by L into T. E power minus R by L into, that's what I have written here. You can see e power minus R by L into T. So this is the inverse Laplace of, okay. So this is it. This is the solution for this step response. Step response means, step response I have already told you. Unit step in, you are given DC input here. So I am considering input as step input. That's why if you remember, what did you write? V of t is equal to, what did you write? V of t. Laplace of V of t, what did you write? Laplace of V of t you have written as V by S. So step response. This is it. Okay, so this is the solution for RL circuit in Laplace form. Okay, solution of RL circuit in Laplace form is this. Anyone, if you want me to repeat the same concept again, I will repeat, or if we will go for numerical problem, you will have some more. Same thing I am going to repeat in the numerical problem also. So I hope you have written. I am moving further to the numerical problem. So this is our numerical problem. So in the series RL circuit shown in the figure, we have to determine the I of t. So I of t, this is the given RL circuit. Okay, input is V0 e power minus alpha t. This is alpha. E power minus alpha. This is minus alpha t. Okay, that I will write it here. V0 e power minus alpha t. This input is V0 e power minus alpha t. Minus alpha. Okay, input is V0 e power minus alpha t, and we are assuming that current I of t flows in this circuit, and resistance and inductor are there. It is RL circuit. So applying KVL, okay, applying KVL, Kirchhoff's voltage law, what is it? V0 e power minus alpha t, e power minus alpha t is equal to R into I of t plus L into di by dt. Okay, this equation we can easily write it down applying KVL. You can easily write down the equations. KVL equation. So write down the question and draw the circuit. So I hope you have completed. Okay, so simple circuit, RL circuit, not RC, sorry. RL circuit, simple RL circuit is there. So we have written KVL equation for this. Okay, we have written KVL equation for this. Now what we have to do, you have to take the Laplace transformation of this. Okay, so you can see here V naught magnitude is its constant, e power minus alpha t. So e power minus alpha t, if you take the Laplace transformation, what will happen? E power minus alpha t, Laplace transformation of e power minus alpha t is 1 by s plus alpha. So write down taking Laplace transformation. First term V naught e power minus alpha t was there. So instead of V naught, you keep it as it is. And e power minus alpha t, instead of that, you write 1 by s plus alpha, r is constant. Instead of I of t, write I of s. And L into di by dt, isn't it? Di of t by dt. So L into s I of s plus current in the circuit as soon as switch is closed. Current in the circuit as soon as switch is closed. Okay, that is initial current. I of 0 plus means what? It is the initial current as soon as switch is closed. So I have already told you in the theory that immediately as soon as switch is closed, current cannot flow in the inductor. Current cannot flow in the inductor. Therefore, at t equal to 0 plus, current in the inductor is 0. Okay, current in the inductor is 0. So I of 0 plus is 0. So above equation will be modified as V naught into s plus alpha, that is equal to r into I of s plus L into s I of s. Because this term is equal to what? Initial current is 0, because immediately current cannot flow in the inductor. So initial current is 0. So that's it. Take I of s common. So you will get V naught 1 by s plus alpha equal to I of s into r plus s L. Okay. So what is I of s is equal to? I of s is equal to V naught into 1 by s plus alpha into r plus s L. So write down those equations as quickly as possible. We'll proceed further. I hope you have written. Okay, so nothing is there. Simple. Whatever we have done in the theory, same thing we are doing here also in the numerical problem. Here they didn't specifically give us any numbers, isn't it? In the circuit, they have mentioned RL. Simply input is bit different. That's it. Nothing else. So I hope you have written. Let us proceed further. Okay, so what is our I naught? I naught is, what is our current? I of s? I of s is equal to V naught into 1 by s plus alpha into r plus sf. If you carefully observe, this is s plus alpha, this is r plus sl. So there is a coefficient of s and we don't want coefficient of s. We want terms to be in s plus something. Okay, s plus a, b, c, d, e, f, g, h, whatever. We don't want the coefficients of s. So we will modify the circuit and remove the coefficient of s here. We will modify this term. So if you want to modify this term, you have to take L common. So take L common. So see here, I have taken L common. If we take L common, what will happen? So 1 divided by s plus alpha plus s plus r by L you will get. Okay, so here V naught by L is constant. You can send it to the numerator. Okay, you can rewrite this equation. Okay, you can rewrite this equation as shown here in the next term here, which I have shown here. So you can rewrite it. So here I am going to take two conditions here. First case is when alpha is not equal to R by L. First case is alpha is not equal to R by L. Okay, when alpha is not equal to R by L, first case. And second case I will consider alpha equal to R by L. So first case I am considering alpha is not equal to R by L. That's it. Simply I have mentioned it, and I have written this equation as it is in the here. As it is I have written. So here in the denominator I have two terms, s plus alpha and s plus R by L term. So go for partial fractions. Okay. I am going to, by using partial fractions, I might have written here. Using partial fractions. Okay. So I might have written here. I didn't write it. I will just write it down. So using partial fractions, I of s is what? You can rearrange the terms and you can write it as a by s plus alpha plus, no need to rearrange, just remove the denominator and write a plus s plus alpha and b by s plus R by L and determine a value and b value. So determine a value and b value now. So what is a? A is equal to what? I of s into s plus alpha, denominator of a. Okay, I of s into denominator of a. At s is equal to what? Equate s plus alpha to 0. If you equate s plus alpha to 0, s will be equal to minus alpha. So s will be equal to what? Minus alpha. So a is equal to I of s into s plus alpha at s is equal to minus alpha. So what is I of s? I of s is V naught by L whole divided by s plus alpha and s plus R by L into s plus alpha at s is equal to minus alpha. Now from this what I can do? S plus alpha cancel. What is left over? V naught by L by s plus R by L at s is equal to minus alpha. Okay. Now substitute s is equal to minus alpha. Here s is there, isn't it? Substitute s is equal to minus alpha. So V naught by L by minus alpha plus R by L you will get. Now rearrange the terms. What do you get? V naught by R plus, R minus alpha L. V naught by R minus alpha L you will get, because alpha is minus A. Okay. So this is my A. So I might have given some numbering to these terms, but I didn't give. Already I have made many modifications to make it more simple and easy to understand. I didn't have time to give numbering also. For some terms I have given, for some terms I didn't give. So just write it down here. So I hope you have written. Similarly, determine B. So to determine B, what is B equal to I of S? Okay, I of S into S plus R by L at S is equal to R by L. Here at straight line should be there. It is missing. Okay, so B is equal to I of S into S plus R by L at S is equal to minus R by L. Okay, so this is the denominator of B, isn't it? So you have to multiply I of S with the denominator of B and You must equate r plus r by L to 0. When you equate it, you will get S is equal to minus r by L. That's it, nothing else. So what is I of S? V naught by L by S plus alpha into S plus r by L into S plus r by L at S is equal to minus r by L. So S plus r by L, S plus r by L cancel. What is left over? V naught by L by S plus alpha at S is equal to minus r. Now substitute this S here. You substitute what you get? V naught by L by minus r by L plus alpha. Just rearrange the terms. You will get B is equal to minus V naught by R minus alpha L. This is what you will get. Okay. So this is D. Write it down quickly. I hope you have written B value. Now substitute A value and B value in current equation. What is I of S? A value is how much? V naught by R plus alpha T. This is A. Okay, this is A. Okay, whole divided by S plus alpha plus B value. This is B. Okay, B divided by S plus R by L. So B is minus V naught by R plus alpha. A is V naught by R minus alpha. Okay, B is minus V naught by R minus alpha L. This is A is V naught by R minus alpha L. I am not even reading properly. Okay, I have written everything here, but I am not even reading properly. So now just you can see in the numerator V naught by R minus alpha L, and here minus V naught by R minus alpha. Both terms are same, isn't it? You can take them common. You just take it common. V naught by R minus alpha L you will get. Okay. So after that, if you take it common, what is left over? Coefficient to this you will get 1 by S plus alpha minus 1 by S plus R by L. So you just observe here 1 by S plus A minus 1 by S plus A form is there. So if you take the inverse Laplace of this term here, this is constant. Okay, write it as it is. If you take the inverse Laplace, to determine inverse Laplace is to what? To determine current in time domain. Okay, so we want to determine the current in time domain here. So instead of directly determining the current, we are going for algebraic equations. Instead of directly writing the current equation in differential form, we are going for algebraic equations here, nothing else. So this as it is, you just write it down while taking the inverse Laplace. Here this equation was in I of S form. Now I am converting it into I of T form. So this is constant, leave it as it is. What is the inverse Laplace of 1 by S plus alpha? It is e power minus alpha T. This is it. Inverse Laplace of 1 by S plus R by L is e power minus R by L T. Okay. So exponential term inverse Laplace as well as Laplace terms you must remember. So this is I of T for the given circuit. Okay. For what? For case 1. Case 1 is, what is case 1? We have assumed alpha is not equal to R by L. Okay, let us go for case 2. Let us go for case 2. So just write it down quickly. If you have written, I hope you have written. So I hope you have completed. If not completed, just mention. I will go back. Now case 2. Let us go to case 2. What is case 2? We are assuming here What are we assuming? We are assuming alpha is equal to R by L. Alpha equal to R by L means instead of R by L, what you should write in your I of S equation? I of S, you see here, it was S plus alpha into S plus R by L was there. Instead of R by L, what did I write? I wrote alpha. Instead of R by L, I have written alpha. Both are equal. When we consider alpha equal to R by L, so this is what you will get the equation. So this is S plus alpha whole square you can write. Okay, so I of S is equal to V naught by L into 1 by S plus alpha whole square. Okay, V naught by L into 1 by S plus alpha whole square. You will get. So S plus alpha whole square. It's if you take the inverse Laplace of this I of S, okay, you'll get the I of t. V naught by L is constant. Leave it as it is. So what is the inverse Laplace of 1 by S plus alpha t square? It is t into e power minus alpha t. Okay, so this is our time domain current when assuming that alpha is equal to R by L. Okay, I hope you have understood. Even if you have not understood, it's okay. If people are writing it down in your notes, so you just go through it later, you will be able to follow. So this is about RL response for DC circuit using Laplace transformation. I will discuss RC and I will conclude as quickly as possible. So let us go for okay. I will discuss RC also and I will conclude as quickly as possible. So RC circuit DC response and solution using Laplace transformation. RC circuit. So you can see here there is a resistor, there is a capacitor, and this is our DC voltage source. Because of V of t, I of t current flows, the voltage across the capacitor is Vc of t. Okay, write the title, draw the diagram. Write the title, draw the diagram. I hope you have completed RC circuit. Okay. So if you are listening carefully, even if you have doubts, those doubts will be clarified in this topic. I hope so. So initially capacitor will not be charged. Okay, capacitor will not be charged. Voltage across the capacitor will be 0. So voltage across the capacitor initially at 0 that means that capacitor acts as short circuit as soon as what? As soon as switch is closed. Okay. So we have to remember one thing, that as soon as switch is closed, inductor acts as open circuit, capacitor acts as short circuit. Okay. So current in the inductor as soon as switch is closed is 0. Voltage across the capacitor as soon as switch is closed is also 0. That means that at t equal to 0 plus Vc of t will be equal to 0. Vc of t will be equal to 0 as soon as switch is closed. So first of all, let us apply KVL and write the KVL equation. So when switch is closed, we can get the solution for this circuit. So what is applying Kirchhoff's voltage law? So what is the equation? V of t is equal to what? R into I of t plus. I didn't write the voltage equation across the capacitor. I know the equation, but I didn't write. I have written Vc of t. Okay. So because as I have already told you that as soon as switch is closed, voltage across the capacitor will be 0. Means capacitor is acting as short circuit as soon as switch is closed. That's why instead of writing voltage equation, I have simply written the notation of the voltage, that is Vc of t. So what is the current in the circuit? Current equation, I of t, it is acting as a short circuit, isn't it? It is acting as, capacitor is acting as short circuit. So what is the current? C into dV by dt. So V is what? Vc of t. V is the voltage across the capacitor is Vc of t. So current through the capacitor is how much? I of t is equal to, since it is acting as short circuit, as soon as switch is closed, I of t is equal to C into d by dt of Vc of t. So consider equation 1 and 2. Now substitute 2 in 1. Consider substitute equation 2 in 1. That is substitute I of t. Whatever I of t is there in your equation 1, substitute this I of t here. So if you substitute, what do you get? V of t is equal to R into C d by dt of Vc of t plus Vc of t. This is what you will get. That is your equation number 3. That is your equation number 3. Now we have got an expression here. Okay, we have got an expression. What you have to do is now, the people have to go for Laplace transformation. What is expression? Okay. So what is the Laplace of V of t? Can anyone mention in the chat box? If you have heard the previous session, earlier, if you have heard the class, Laplace of V of t is what? V by S. V is constant, magnitude is constant. We are assuming step input here. Okay, unit step input. So that's why 1 by S, V into 1 by S. That is it. Okay, V by S. What is the Laplace of Vc of t? Laplace of Vc of t is Vc of S. Okay, similarly, I might have written small v here. I didn't write. I might have written that. I can do that. I can write here small v, as I have already told you. What did I say? I already told you that in time domain, the terms must be written in small letters. But there was a coefficient to this v. That's why I wrote capital, nothing else. The reason behind why I wrote capital V, reason is, besides that, there is v of c. See, if I write small v, it is assuming it is looking as if it is multiplied with c, isn't it? That's the reason I didn't write the small v. It's okay. It's okay. Okay. So this is it. So v of t is equal to R into C d by dt of Vc of t plus Vc of t. This is it. Now what we have to do? We have to go for Laplace transformation. So go for Laplace transformation. Right? The Laplace of v of t is what? Here step input we are giving, unit step input. So v into 1 by s. So v by s is the Laplace. Okay. So is equal to R into C. Laplace of d by dt of Vc of s. I have already told you. So if there is d by dt term, that is differentiation term, d by dt of x, if there is d by dt of some x, Laplace of d by dt of x. Okay. Laplace of d by dt of x will be what? S into x of, sorry, I am writing I. S into x of s. Okay. X of s. X of s along with its initial condition. What is the initial condition? Initial condition is x of 0 plus. Okay, x of 0 plus. X of 0. 0 means the time immediately after closing the switch is known as 0 plus. Time immediately after closing the switch. 0 plus. So Laplace of d by dt of x is x of s plus x of 0 plus. That's what I might have written here. Let us see. Laplace of v of t is v by s, RC constant. Laplace of d by dt of Vc of s is s into Vc of s. Okay. Plus Vc of 0 plus. Here I have written minus because the capacitor is initially charged. Okay. It is acting as short circuit, means even though whatever charge that is there, okay, So it will discharge in the opposite direction. Okay, whatever charge is developed in the capacitor, okay, even though it is acting as a short circuit, whatever voltage already earlier some charge will be there, that will discharge in the opposite direction. Therefore, minus Vc of 0 plus. Okay, so capacitor will discharge into the circuit in the opposite direction to the current flow in the circuit. Okay, since it discharges in the direction which is opposite to the actual current flow direction in the circuit, that's why minus Vc of 0 plus. Okay, so this is it. D by dt of Vc of t, Laplace of d by dt of Vc of t, what you get? S into Vc of s minus Vc of 0 plus Vc of t is that, so instead of Vc of t, write Vc of s. Now here, what did I say? As soon as switch is closed, capacitor acts as short circuit. So initially the voltage across the capacitor is 0. Initially voltage across the capacitor is 0. So Vc of 0 plus is how much? It is 0. Vc of 0 plus is 0. I might have written somewhere when switch is closed at t equal to 0. So voltage across the capacitor is 0. Voltage across the capacitor is 0. Means as soon as switch is closed, so capacitor acts as short circuit. So no voltage is developed across the capacitor plates. Okay, voltage is not developed across the capacitor plate, so it is 0. So Vc of 0 plus is 0. So what is it? V by S is equal to Rc into S Vc of S marked. Okay, so here this is become 0, so plus Vc of S. This term becomes 0. So then take Vc of S common. So V by S is equal to Vc of S into 1 plus S Rc. 1 plus S Rc. This is what you will get. Okay, so again if you observe carefully, there is some term which is coefficient of S, and I don't want coefficient terms. I don't want coefficient terms. I want to remove it. I want to remove the coefficient terms. So I hope you might have written. Meanwhile, I was giving explanation. Meanwhile, I was explaining the concept. I hope you people might have written. I'm changing the slide. If you want me to go back, you can mention in the chat box. So there, what did I do? What did I do? From previous slide to this slide, what did I do? So it was V by S is equal to Vc of S into 1 plus S Rc. So I have written equation in terms of Vc of S. Okay, so I have written in terms of Vc of S equal to what? V by S by S into Rc plus 1. So take Rc common, you will get V by S by Rc into S plus 1 by Rc. Send this R to just rearrange this S and Rc. Okay, you will get Vc of S is equal to V by Rc by S into S plus Rc. Now here I have two terms. One is S in the denominator and another term is S plus 1 by Rc. Now my aim is to determine the voltage across the capacitor in time domain. It is in Laplace form now. Vc of S means it is in Laplace form. I want Vc of t. So here what we are doing, we are using Laplace transformation method to determine the voltage across the capacitor. Okay, that's it, nothing else. Okay, so I want Vc of t. For that, what I have to do? I have to go for partial fractions. There are two terms in the denominator. So a divided by s plus b divided by s plus 1 by rc. So Vc of s is equal to what? A divided by s plus b divided by s plus 1 by rc. So I hope you have written this, what I am showing you here. So I'm going for partial fraction. So using partial fraction, Vc of s is equal to what? V by rc whole divided by s into s plus 1 by rc. Okay. So that is equal to a divided by s plus b divided by s plus 1 by rc. Consider it as, give some numbering I have written here. I may not mention again and again to give the numbering. You just write down on your own. Now determine A value and B value. So let us determine A value. A is equal to what? What is it? Our equation VC of S. So VC of S into denominator of A is S. At equate S to 0, S is equal to 0. So what is VC of S? V by RC by S into S plus 1 by RC into S at S is equal to 0. Now this S will be cancelled. What is left over? V by RC by S plus 1 by RC at S is equal to 0. Now substitute S value here 0. So V by RC by 0 plus 1 by RC. So V by RC by 1 by RC, RC cancel, left over is V. So A value is equal to V. Write it down, all of you, quickly. I hope you have written A. So let me check whether I am online or not. Okay then. Now let us determine B. What is B? B is VC of S. VC of S into denominator of B is what? S plus 1 by RC. S plus 1 by RC at S is equal to what? Equate S plus 1 by RC to 0. You will get S is equal to minus 1 by RC. So B is equal to what? V by RC by S into S plus 1 by RC. So S plus into S plus 1 by RC at S is equal to minus 1 by RC. So S plus 1 by RC, S plus 1 by RC cancel. What is left over? B is equal to V by RC by S at S is equal to minus 1 by RC. So substitute S is equal to minus 1 by RC here. Just substitute it here. Substitute it here. What is left over? What do you get? V by RC by minus 1 by RC. 1 by RC, 1 by RC cancel. B is equal to minus V. B is equal to minus V. That's what you will get. So I hope you have completed B. So now substitute this b value, a value in your VC of S equation. So if you substitute them in VC of S equation, so you will get this. VC of S is equal to what? V by S plus minus V by S plus 1 by RC. So you just take V common, you will get VC of S is equal to V into 1 by S minus 1 by S plus 1 by RC. Okay, so now we have got an expression for VC of S. So capacitor voltage in terms of Laplace form, in Laplace form. Okay, this is capacitor voltage in Laplace form. Now convert that into time domain. Okay, convert that into time domain. So some of you might have a doubt that what is the need to determine this voltage in Laplace, and later on what is the need to convert that into time domain. This is one of the method. Okay, we are following one of the method to determine the voltage across the capacitor or current flow in the circuit due to inductor. Okay, so this is one of the method to determine the voltages or currents in the circuit. The method is what? Laplace transformation method. Using this Laplace transformation method, we are trying to determine the currents or voltages in the given circuit. That's it, nothing else. Okay, so we must know different methods of solving the circuit, isn't it? So we are using Laplace transformation method. If you remember the formulas of Laplace transformation, you can easily solve the numerical problems using the formulas. Okay, so here, so VC of S is equal to V into 1 by S minus 1 by S plus 1 by RC. So 1 by S, inverse Laplace of 1 by S, what do you get? It is 1. What is the inverse Laplace of 1 by S plus 1 by RC? It is inverse Laplace is e power minus 1 divided by RC. That's it. Okay, e power minus 1 divided by RC. Yeah, of t. I forgot t. Okay, 1 by RC of t. So let us go to the inverse Laplace transformation. By inverse Laplace transform, Vc of t is equal to V into 1 minus e power minus 1 by RC of t. So this is the step response of RC circuit. Okay, that's it. We will discuss a small numerical problem and we will conclude this topic. So remember that Laplace transformation is one of the methods to determine the voltages and currents in the given circuit. So I hope you have completed. Let us see a numerical problem. So in this numerical problem, a 20 volts is applied across RC circuit having R value 12 ohms, capacitance value 14 farad. Find the voltage and current after switch is closed at t equal to 0. So as soon as switch is closed at t equal to 0, so we have to determine the voltage and current. So we have to determine the voltage and current when switch is closed at t equal to 0. So here R value is 12 ohms, C value is 14 farad. Okay, supply voltage is 20 volts. So write down the question and draw the circuit. So maybe within 10 minutes I will conclude this session. So I hope you have written. Now just apply KVL as soon as switch is closed. After immediately after closing, just apply KVL. What do you get? 20 is equal to V is equal to R into I of t. R is 12, I of t plus voltage across the capacitor. I'm just writing Vc of t because I want to substitute the initial condition, isn't it? Here switch is there, so we have to consider the initial condition. So Vc of t. So now what is the current in the capacitor? Current in the capacitor C into d by dt of Vc of t. What is C value? 14. So 14 into d by dt of Vc of t is the current in the capacitor. Okay, so this is it. Just write down these equations. Equation 1 and equation 2. Hope you have written. Now substitute 2 in 1 IC of current I of t in the above equation 1. So 20 into 12. Sorry, 20 is equal to 12. Right, I just forgot to make this visible. Okay, so 20 is equal to 12 into C d by dt of Vc of t plus Vc of t. So 20 is equal to 12 into C value. How much? C value is how much? 14, isn't it? So instead of writing C, I might have written here 14. Huh? I might have written here 14. Okay. So is this correct? Is 12 into 14 how much? Can anyone tell me? Is it 168? 12 into 14? I don't know. Just calculate it. I have written here, but I just have it all. So if my calculation is right or not, just check it. If it is wrong, you just inform me. If I have done wrong calculations, 12 into 14, just multiply and d by dt of Vc of t plus Vc of t. This is it. This is our equation. So now what we have to do? Apply Laplace transformation to the above equation. So 20 by s. Okay, 20 into 1 by s. Okay, 20 into 1 by s. We are considering here unit step response, unit step input. That's it. Unit step input. That's why always we are writing to whatever v value is there, v into 1 by s. 168 is constant into d by dt of Vc of t. What is the Laplace of it? S into Vc of s minus Vc of 0 plus. And Laplace of Vc of t is Vc of s. That's it. Just write it down quickly. Write down quickly. Now, what we have to do after writing the Laplace equation? We have to consider the initial condition. Means as soon as switch is closed at t equal to 0 plus. What about the voltage across the capacitor? Voltage across the capacitor will be 0. Why? Because immediately after closing the switch, capacitor acts as short circuit. So voltage developed across the capacitor is 0. So I hope you have written whatever is there in this slide. So I will change this slide. So what is it? So as soon as switch is closed, voltage developed across the capacitor is 0. That is Vc of 0 plus is 0. So what is left over? 20 by s is equal to 168 into s into Vc of s plus Vc of s. Now take Vc of s common, you will get 1 plus 1 Vc of s into 1 plus 168s. That is equal to 20 by s. So what is Vc of s? 20 by s by 168s plus 1. So if you remember, I have already told you if there is any coefficient besides to the s in the denominator, You have to remove that coefficient, that's it. You don't have any other option to go for partial fractions to determine Vc of t. So our aim is what here? To determine the Vc of t, that is voltage across the capacitor. Our aim is to determine the voltage across the capacitor. Just write down these equations quickly. So I hope you have written. So take 168 common, and if you take a 168 common, what do you get in the denominator? 168 if you take common, you get 168 into s plus 1 by 168. So Vc of s is what now? Vc of s is equal to 20 by s whole divided by 168 into s plus 1 by 168. So Vc of s is equal to, you can just replace the positions of s and 168. So v by 168 by s into s plus 168. So in the denominator we have two terms. One is s, another one is s plus 168. So we can go for partial fractions. So by using partial fractions, what do you get? Vc of s is equal to a by s plus b by s plus 1 by 168. Okay, write down this. Okay. Write down these equations quickly. So I'm about to finish. Okay, I hope you have completed. Now go for partial fraction, determine a value. What is a? Vc of s into s at s equal to 0. Okay, so what is Vc of s? 20 divided by 168 by s into s plus 1 by 168 into s at s is equal to 0. So this s will be cancelled. What is left over? 20 divided by 168 by s plus 1 by 168. Substitute s equal to 0 here. What is that? 20 divided by 168 by 1 by 168. So 168 cancel, a is equal to 20. Just write down quickly a value. I was making all these modifications earlier. That's why I couldn't start the class on time. Okay, on the scheduled time. So I hope you have written. Now let us determine B. So B is equal to Vc of s into denominator of B, s plus 1 by 168. So at s is equal to what? S is equal to minus 1 by 168. Okay. So B is equal to what? 20. Vc of s is 20 by 168 by s into s plus 1 by 168 into s plus 1 by, here I have written RC. I just forgot to modify this. I just copied the theoretical part and I just modified, I replaced the theoretical values with practical values, and for this one term I forgot to change. So okay, so B is equal to 20 divided by 168. 20 divided by 168 by S into S plus 1 by 168 into S plus 1, 1 by 168 at S is equal to minus 1 by 168. This term, they will cancel. Sorry. What is left over? 20 divided by 168 by S. At S is equal to minus 168. Minus 1 by 168. Substitute instead of S. Substitute, write this. Okay, if you write this instead of S, what do you get? B equal to 20 by 168 minus 1 by 168. So 1 by 168, 20 by 168. 168, 168 cancel. Left over B is equal to minus 20. So you might be wondering why there are both are numerical terms. Why I did not divide? Why? Because at the end we were able to cancel because I didn't simplify above. Okay, since I didn't simplify the above expression, that's why I was able to modify it. Okay, or easily cancel, isn't it? So we have got an expression for some term, some value, not term. We have got a value for A. We have got a value for B. Now you can substitute this A value, B value in your VC of S equation. Write it down quickly. I hope you might have completed. Now substitute A value and B value in VC of S equation. So VC of S is equal to what? A is 20. 20 divided by S plus minus 20 by S plus 1 by 168. Okay. So don't confuse why I have written this term. This is the term which you have modified and written in this partial fraction form, if you remember. Okay. So substitute A and B value, and A and B value, if you see, magnitudes are same. So take 20 common. VC of is equal to 20 into 1 by S plus 1 by S plus 1 by 168. So what is the inverse Laplace of 1 by S? It is 1. Inverse Laplace of 1 by S plus 1 by 168, what is it? E power minus 1 by 168, isn't it? If you are listening carefully, you might, by now you might be remembering the inverse Laplace of these terms. E power minus 1 by 168 into t. Okay, so hope so let us go for inverse Laplace transformation to determine the voltage across the capacitor. So applying inverse Laplace transformation, this is what you will get. Okay, this is the voltage across the capacitor. So inverse Laplace of 1 by S is 1. Inverse Laplace of 1 by S plus 1 by 168 is e power minus 1 by 168 t. Just write it down. They have asked us to determine the voltage as well as current also. So we have determined the voltage. So I'm about to finish. We'll determine the current and we'll conclude this. Okay, I have determined the voltage till now. We have determined the voltage across the capacitor. Now let us determine the current in the circuit. So let us determine the current in the circuit. What is the equation of current? What is the equation of current? Current is equal to what? I of t is equal to 14 into d by dt of Vc of t. We have got an expression for Vc of t from equation 2. This is our equation 2. So what is the expression of Vc of t? Just now we have calculated. So what is Vc of t? This is Vc of t. Just now we have calculated. Vc of t is equal to 20 into 1 minus e power minus 1 by 168t. So just substitute that here. So I of t is equal to 14 into d by dt of Vc of t. What is Vc of t? 20 into 1 minus e power minus 1 by 168t. Okay. So 20 is constant. Send it outside of this differentiative. So 14 into 20. Okay. So I of t is equal to 14 into 20 d by dt of 1 minus e power minus 1 by 168t. Okay. So if we differentiate 1 with respect to d by dt, you will get 0, nothing else. So d by dt of e power minus 1 by 168, you will get e power minus 168t minus 168t into minus 1 by 168t. Here 14 into 20, you will get 280. So I of t is what? How much? I of t is minus 1.666 e power minus 1 by 168t amperes. Amperes is the units. Okay, this is what you will get. Write it down quickly and this is over. That's it. So we have discussed the RL circuit, DC response and solution using Laplace transformation, and we have discussed RC circuit DC response and solution using Laplace transformation. Okay, so for this simply what is the reason to follow the Laplace transformation, use the Laplace transformation is it is one of the method to determine the voltages and currents in the circuit. So if you want to use the Laplace transformation method to determine the voltages and currents in the circuit, then what you need is you have to learn the formulas. Okay, so what the time domain terms, if you take the Laplace of time domain terms, what will be the Laplace form? And if you have the Laplace terms, that is I of s, v of s, whatever of s terms, okay, s domain terms, then how to if you take the inverse Laplace of those terms, what will be the time domain terms? So if you remember those formulas, it will be very easy for you to solve the circuit and determine the voltages or currents in the circuit by Laplace transformation method. So sometimes if you are studying BTech, then for your electrical circuits subject in the exam, they may ask you to determine the solution for the given circuit or determine the voltage or current using Laplace transformation method. So if they ask you, you don't have any other option. You have to use the Laplace transformation method to determine the voltages and currents in the given circuit. Okay, that's it. I hope you have completed. If anyone have any doubts, you can mention in the chat box. I will clarify those doubts. I hope you don't have